So we have a couple more least common denominator questions, and then we'll get into the actual when do you use this least common denominator, adding and subtracting. I was telling my other classes, adding and subtracting is the hardest two operations with fractions, and that's all we're dealing with here is rational fractions. Rational expressions are just fractions with variables in the denominator. So when you add and subtract them, you've got the hardest one in the rearview mirror. Because when you add and subtract rational expressions, you need like denominators. And that is what we're working on right now. 11 was a good example of what happens when your denominators have some characteristics. That we haven't faced yet. So the two fractions are 15 over 3x squared minus 12x minus 135 and a negative 3 over 21x squared minus 525. So when there is a leading coefficient other than 1, I automatically think bottoms up. I forget about check for GCF first. We haven't had a GCF example yet. So we look for a GCF before we go factoring denominators. The other ones didn't have one, so I never mentioned it, but that's always the pre-step. Like 3 will go into all of these terms. So if I take a 3 out, I get an x squared minus a 4x minus, I don't know what it is, 45. So that could be tricky when you're dancing with two fractions you want to add together and you're factoring the denominator. Watch out for the GCF, greatest common factor of all the terms. We're talking about GCF, and then we're finding the LCD, least common denominator. So the 3 still lingering. Factors of 45, 1 subtract to give me 4. 1 and 45, 5 and 9. 5 is positive. 9 is negative, because it's got to match that sign in the middle, the larger value. When you check it out, negative 9 plus 5 is negative 4. You're right. Negative 9 times 5 is negative 45. You're right. You are right. So we're done with that factoring. Here we look for GCF. I did not know 21 goes into 525. Crazy, crazy, crazy. I would have never guessed 525 is divisible by 3 and 7. Crazy. Numbers. Always got to check them. So this guy is a difference of squares. Now we're all ready to follow the directions, find the LCD. Great example. A factoring. Now, do you see how 3 and 21, the other numbers, the constant factors before, never had anything in common. But 3 and 21, 3 goes into 21. So the smallest number that 21 can go into is 21. And the smallest number here, 3, can go into 21. So it has to be in common. So they both have a factor of 3, and this one has a factor of 7. That's why it's a 21. See why we don't use 63? Because that's not the smallest. It needs to be the least common denominator. So in your homework, watch out. Number 11 especially, you probably have something in common so that in the LCD it's going to be one of these two numbers. Whether they're like or different. So Now we just write down our rest of our factors. So I need an x plus 5 because it's in both. I need an x minus 9 because it's in one of them. And I need an x minus 5 because it's in the other. X plus 5 is only listed once. So that's why we only list it once in the LCD. So that's a big one. That's number 11. What you'll enter into your software. How's your brain? Think in numbers? Think of factors? And then you just put the factors that either one of them have here. That becomes the least common denominator. So now our radar, my radar is out for least or greatest common factors. My purple one is fading a bit. Let's see if my blue one's up to working. So when I have a leading coefficient other than 1, I think, ooh, does it go into all the terms? This one's not much better. This one's skipping around too. Okay, let's try this one. My rainbow. No, it's here. Order some more erasable pens. Okay, that's my first fraction. Still don't like it. Another dark one. The green one will work. And here's my second fraction. Negative 1 on top. And negative 7x squared plus 70x minus 147. That's pretty. That's still not very good, is it? If I make it so it isn't so shiny. Better. A little bit. That yellow kind of makes it crazy. Okay, so everybody's got a 5. I love 5s. 5s are fun. X squared minus 10x plus 21. This guy has a negative 7. I see 7s in the story. So take out a negative 7. I am desperate. Holy Toledo. I'd have to succumb to a normal pen. I never use a red, but we'll see if this works. I think I got a dud bunch. I just ordered some new ones. Okay, x squared plus, oh no, no, no. If I take a negative out, it has to go negative. Minus 10x plus 21. And if you notice, these polynomials match. That's kind of nice. You can even see them. Not too bad. Okay. Now they're alike, so I can just like write them LCD, right? No, we still have to factor because they want the answer in factored form. So factors of 21 when added give me a negative 10. X minus 3 and x minus 7. And over here, it's x minus 3 and x minus 7. And I see multiply 5 and negative 7 have nothing in common. So my LCD, well, that one worked for a minute. It's 5 times a negative 7. and then the two binomials. Okay. One isn't working too bad. That is our last LCD question. So we're finally, these last 7 will be adding and subtracting fractions that have variables in the denominator. Go for the 7 over 5 plus x plus 5 minus x over x. They don't give us too complicated binomials, but they kind of mess with the signs and stuff, so you have to be on alert. You know, be ready. And I learned this when I think I was substituting in the Lex Middle School back in 2003, maybe. Mrs. Gloria Orita Simonson taught me the fast way to add fractions that have different denominators. Because 5 plus x and x have no factors in common, I can just take the denominator of one and multiply it to the numerator of the other. So have you guys seen this? Someone said it's like the butterfly method. And all I'm doing is creating a least common denominator. So I'm not breaking the rules of the universe. It just goes quicker if you just take that bottom denominator on the right and multiply it to the numerator of the first one. Bottom of the denominator in the second one, move it over to the numerator, multiply it times the numerator of the first one. Has anybody seen this? Shortcut? Probably not with polynomials. Are we watching? Shouldn't have a ear thing in your ear. Okay, you want to take your, thank you. Okay. And so we're adding it to whatever this denominator times this numerator is. So we're going to add it to 5 plus x times 5 minus x. I'm trying to make up my own story here. Then my common denominator just comes from those two multiplied together. You don't multiply them together. They're just shown as being multiplied together. Like the x on the front because it's a constant, you know, just one factor. And then we put the 5 plus x as the other factor in the denominator. So this is the LCD. But because these two had nothing in common, I could go straight to using the butterfly method to write my one fraction. Only thing that's left, we have to multiply those two polynomials together, which you guys are great at, and combine my terms and write it in standard form. So 7x is 7x, 5 times 5 is 25. This is a plus, so we don't have to be concerned about changing any signs. So with subtraction, it gets a little messier. And then negative 5x plus 5x is 0. So I don't have to write that down. I can just write the next term down. X times a negative x is a negative x squared. Then I have my denominator. And this is not standard form. And just to be sure, just good practice, we're going to rearrange the terms in the numerator. Negative x squared is the highest power, plus 7x is the next highest, and then plus 25 is my constant term, all over the x times 5 plus x. We're done. Oh no. I have to tell you what the excluded values are as well. So this will go in your sum. What's the sum of these two fractions? As well as what is the no-nos for x? Here, the excluded value is x equals 0. Here, the excluded value is x equals a negative 5. So they're using the equal sign instead of the not equal sign because they're using the language, what are the excluded values? Therefore, they say x equals 0 is an excluded value and x equals a negative 5 is an excluded value. So that's why they use the equal sign. They have them there. All you have to do is type in the values for number 13. So they ask you to put in your result as well as excluded values. If one of these disappeared from simplification and cancellation, then you always go back to the original denominators for the excluded values, but these denominators are the same. They started with these two denominators. They end with these two factors as the denominator, so that's why I used them to get my excluded values. Okay? I don't know if you want to tag that or not. Excluded values. Nothing can be 0 in the denominator. So that is why we've been doing everything up to this point. Found the excluded values, found the LCD, and we used our prior work with polynomials to be able to multiply, combine like terms, write in standard form. If we had to, we could simplify this, but there's no factors of 25 when added give me 7 that I could factor this polynomial and do more canceling. Okay, but always, that's always lurking there. Land of Oz, all they want you to do is be able to add two fractions. It gets messier. All I can tell you. Okay, 14. See what the fractions are there. The simple ones, 2 over 8 plus x minus, maybe not so simple, 8 minus x over x. This is a booger. So you can distribute that subtraction sign to the numerator now, or you can distribute it later. And depending on what the numerator is what I distributed. So, and it's your preference. And I'm going to go ahead and not distribute it yet. When you do my butterfly, 2 times, because 8 plus x and x have nothing in common, that's going to be my least common denominator, x times 8 plus x. I take my x times the 2 and my subtraction sign, and then I get to multiply these two, x plus 8 times x minus 8. I'm sorry, 8 plus x times 8 minus x. I said x. 8 plus x is like, no, that's not right. But you can write it either way, it's like, I'm going to write it the way they have it. They got it for a reason. I'm not going to mess with their plan. And then x goes in front because it's the solo factor. 8 plus x is your other factor in the denominator. So I have 2x minus, and I'm going to still keep the parenthesis because after I multiply these two, I have to distribute that subtraction. So that's 64 negative 8x plus 8x minus x squared. So I don't write the negative 8x plus 8x because it equals 0. But I still FOIL because just in case it doesn't disappear, I'm ready. So it's x parenthesis 8 plus x. You get to distribute the negative. So I have a positive x squared, a plus 2x, and a minus 64. Oh, can't see it. So So one step at a time, very carefully, write carefully, don't be messy, be neat, and ask yourself, are there factors of 64 when subtracted or give you 2? And there is not. 4 times 1, 6, 4 times 16, 8 times 8, 1 times 64. That's it. So all I have left is to come up with my excluded values. Since those are my original denominators, my excluded values are x equals 0 and x equals a negative 8. Because excluded values are the 0 of the denominator. Right? You're listening, you're learning. Math memory is building. Strong, strong, strong. Half a page for one, and that one is pretty simple. Just take your time, be neat, give yourself plenty of space. Number 15. 3x to the 4th plus 8, that's an interesting binomial, over x squared plus 1. That's a nice denominator. We're subtracting 11 over x squared plus 1. Yes, that could happen. We already have like denominators. So I can just put over x squared plus 1 these two numerators. 3x to the 4th plus 8 minus 11. So this time I just, move my minus to my numerator. So no harm, no foul. Combining like terms. That's 3x to the 4th minus 3 over x squared plus 1. So the numerator can be factored. 3 times x to the 4th minus 1. So you got to know the game, right, guys? Looking, always looking. Can I factor? Can I factor? Can I factor? So x to the 4th minus 1 can be factored. So we will. Square root of x to the 4th is x squared. Square root of 1 is 1. So this is the difference of squares. Where there's 1, there's always craziness like this. I'm going to go ahead and hug my denominator so you can see how those two cancel. And there's more factoring. X squared minus 1 can be factored. So my final answer is 3x minus 1 times x plus 1. I go back to this denominator, and there is no number that I can square and add it to 1 to be 0. So there are no excluded values. And they have a drop-down menu on number 15, where I'm not sure for sure the verbiage, but that's the one you pick that states something about there are no excluded values. That's for your drop down. And now you've seen that happen. That could happen. Which is nice. So if I put this pretty little thing into decimals, I'll see a graph that has a continuous curve. Nothing gets excluded in the real number system. And this answer didn't even have a denominator but 1, so that was kind of fun. That could happen too. It's just, getting you familiar with all the ways that when you add two rational expressions, what could happen. And And there are more. Ready? Okay, 16. I'm going to go to new page. I'm happy when I see an addition problem because negatives and I are frenemies. I have to live with them, but I don't like them because I make mistakes with them, and that's not their fault. Well, that's nice. There's an addition sign, but that one's a little weird. These two are almost alike, but one is opposite of the other one. So how do you deal with the opposite polynomial so you can make it look the same? That is the question. That's what they're checking your understanding on, because we're supposed to already know this. The only new thing is that we are, making like denominators and then adding the numerators and simplifying. So here, you can think of it as factoring out a -1. Sure enough, see, -1 times x squared is -x squared. -1 times -2 gives me +2. That is not breaking the laws of the universe. And I can move the -1 to the numerator. So then I have myself a reformed fraction with a -2 in the numerator over the original x squared minus 2 denominator. I just did the little magic, little negative magic that allows me to dance that dance. Like denominators, it's x to the 4th minus 2 minus 2. X to the 4th minus 4, x squared minus 2. Combine, like terms. Your difference of squares alarm should go off. And I'm going to go ahead and move it down here. That's x squared minus 2 times x squared plus 2. Did I make a mistake? I'm going to make sure I'm good. Number 16. Yep, okay. Over just one denominator, x squared minus 2. So those two cancel. My answer is without a denominator, but 1. There we go. But my excluded value comes from the denominator that was, the original one. So if I set this x squared minus 2 equal to 0, x squared is 2. Almost got it. Takes the square root of both sides. There are 2 blanks for the excluded values. And they can be irrational numbers. They just can't be imaginary. Positive square root of 2 and negative square root of 2. There's always 2 roots in algebra 2. Not the primary roots. Not both of them. Yep. So be ready to write square roots like for number 16, okay? That's the game they want you to learn to play on for this example. Every example has a special game, if you haven't noticed. Always something unique and wonderful. This one had negatives and square roots for excluded values. Be interesting to see that on a graph, for sure. Okay, 3 left. You ready? 17 looks nasty because the denominators are trinomials. You get to factor, but don't be afraid. Hopefully you're getting more confidence in your factoring because you're thinking about it. It is a subtraction problem. There we go. 2 trinomials. So I got to factor before I can see what my LCD is. I can't just go boop, boop. I can't do that. Can't do that because these two, nope. Got to have factors before I can see. So this, again, these are just not 2 terms, so we have to factor our trinomials. So factors of 20 when subtracted give me 1. And factors of 10 when added give me 7. Hopefully that's a smooth transition. So I have to think about my LCD. I just don't multiply up because I got some things in common. That's a mess. It's just harder, more difficult when you just, yeah. So this when you start playing in the trinomials, the butterfly method is not useful. So I need an x minus 5, and that shows up in both. I need an x plus 4 because it shows in my first one. And I need an x minus 2 because it shows in my second one. So when I look at my first fraction, I notice I have 2 of the 3 factors I need. So I'm just going to take that numerator and denominator because I don't want to break the laws of the universe. X minus 2. What you do, because x minus 2x over x minus 2 is 1, so you're not breaking the universe, laws of the universe, but you are getting a least common denominator, and you just multiply 1 times x minus 2, and that's part of your numerator. Yeah, I'm going to go ahead and give this guy the negative, so that's a negative 1, so it's a plus negative 1. So when I see what's missing over here, I have x minus 5 and x minus 2. I need an x plus 4. You see it? And times x plus 4. Because I can change that subtraction to adding a negative 1. That's when it's useful to give it to the numerator first before you do anything. And I distribute my negatives, so I have a negative x minus 4. That's my numerator. So this was missing, multiply numerator and denominator. That factor was missing, so multiply numerator and denominator. And we can legally say our LCD, write this out, is x minus 2 times x minus 5 times x plus 4. And we can combine like terms. X minus x is 0. Negative 2 minus 4 is negative 6. And of course, we need our excluded values. That one is x equals 2. This one is x equals 5. And the last one is x equals negative 4. My little parentheses kind of in the road there. There we go. Squeezing myself into that corner. Can you guys see my negative 4 there? Got it? These are excluded values. There we go. So here's your sweetheart, -6 in numerator and beautiful binomials in denominator. And the 3 values, I don't think it says numerical order, so you're good. You are good. That was fun. You know the rules, you can play the game. Two more. 18. How much can it get? How more? What else can they ask us to do? Right? To subtract the given expression, simplify the result, and note the combined excluded values. We're back to binomials. Yay. X squared minus 9. That guy can be factored. Minus x plus 5 over x plus 3. So that's kind of ugly. We have a subtraction of a binomial. So, looks like the LCD is this one. Because 8x plus 3 is in common to both. So this other one just needs, let me do it in a different color. He just needs an x minus 3 to make him have like denominators. See the game? See the game? So we have 4 over x plus 5 times x minus 3, x minus 3 times x plus 3. So we just have to multiply. Don't forget the negative after you multiply, and combine like terms, write standard form. It's like one of the earlier ones we did, except for the least common denominator was one of the two denominators. X squared plus 5x minus 3x, 5 times the negative 3. There we go. I FOILed that. You know, first two, outside 2 plus inside 2, they're like terms. And then last 2 multiply. So, I get to distribute the negative. How are you with that task? I am mistaking. Easily mistaken. Then come by like terms, the 4 and the 15. So negative x squared minus 2x plus 19. That is pretty. 19 is an interesting number. I look to my original denominator, which is what we have here, x, excluded value, x equals 3, and x equals a negative 3. Done. Well, what was interesting about that one? Maybe the negative, and the fact the denominator was one of the two fractions. Yep. Highlighter scribble. There we go. Let's just draw a box around it. I don't know if that's any good or not. Okay. Last one, and I'll let you go. Thank you for your great patience. That one's probably going to take a page. I like to make my space. Reason 19 is important is that it's got fractions for excluded values. Hoot hoot. So you know how to wrestle those alligators. The beginning fractions don't look too bad. Negative 3 over 9x squared minus 16 plus, at least it's an addition, 3x squared plus 4x. Okay, because these can be factored. We're not just going to use the butterfly. That's a difference of squares. 9x squared, square root of that is 3x. Square root of 16 is 4. The other one is 3x plus 4. This guy has an x in common. And look what emerges, 3x plus 4. We are in the land of Oz. So my LCD looks like x, 3x plus 4, and 3x minus 4. So this guy over here, he needs an x. So his new numerator is a negative 3x. This guy over here, he needs a 3x minus 4. Sorry for my budging hand. I wish I was right-handed. That'd be easier, right? Because they're cursed with a left-handed teacher. You guys have any other left-handed teachers? Do you notice? Who else is left-handed? You are, yes. How about your teachers? You have to put up with any teachers? You Dominic. Well, left-handed. Okay. It's a hard world, isn't it? Dominic, you find it? Yeah, it's a challenge. It is. Makes us better, right? At least they don't put us to death like they used to. Who is? Yes, that's right. So another one. Yes. We're crazy, but we love it. Okay, there we go. Yes. All right, have fun. All right, here we go. I got my numerator. See what I did? I just took that times 1, yippity-doo. Got my terms there. Got my x and my 3x plus 4 and my 3x minus 4. And you'll have to notice, see if you're, which teachers are left-handed. Report, come back to report. Okay, negative 3x plus 3x is 0, minus 4, just for fun. I never see them teach, so I never notice what they're writing with, so I'll have to be a noticer too. Denominator, have empathy for us. 4 and 3x minus 4. Okay, what in the world? That was not bad, but what makes this denominator 0? A 0, we got that guy, but if I set that equal to 0, some of you guys could do it in your head. Gotta subtract the 4, but that wouldn't be fair. I gotta show my work. Divide by 3, and so one of them is x equals negative 4 thirds. So we got ourselves a 0. X equals negative 4 thirds. Oh, sorry, you don't have to put in the x equals. It'll just be negative 4 thirds, okay? Friends. And then obviously this guy is going to be x is a positive 4 thirds because you would add 4, just like that. So we have 3x equals 4, divide by 3. Fractions are your friends. As much as they drive us crazy. Most of life is fractions. If you get into any kind of vocation, you're going to find that out. There's fractions everywhere. There you go. We did it. Yay! Oh, just a minute late.